Hello everyone, good afternoon. I'm Mohammad Habibullah. My presentation topic is non-functional requirements for machine learning, understanding current use and challenges among practitioners. So machine learning is an application of artificial intelligence that use big data to produce complex predictions and decision-making systems. And the advances include image recognition, language processing, autonomous systems, and so on. And despite the advances allowed by machine learning enabled systems, it is essential to be aware of certain qualities of machine learning solutions. So here non-functional requirements comes. So Glynn defines non-functional requirements as an attribute of or a constraint on a system where attributes are performance or quality requirements. And in this presentation, I will focus non-functional requirements as quality requirements. And this non-functional requirements has been researched in software engineering field for long time. So this is one of the beginning or old taxonomy of non-functional requirements for software quality, which includes portability, reliability, efficiency, human engineering, testability, and so on as non-functional requirements for traditional softwares, which doesn't include machine learning. So the purpose and motivation of our research, when dealing with machine learning enabled software, it is not clear if our accumulated knowledge concerning non-functional requirements are still applicable or not. Some non-functional requirements such as fairness, explainability become more prominent. Others such as privacy remain relevant, and perhaps others, for example, usability, interoperability become less relevant. Further and yet unexplored non-functional requirements such as retrainability may also become relevant in machine learning enabled systems. And in order to begin to answer how our knowledge of non-functional requirements should be reconsidered, we need to understand the state of practice concerning non-functional requirements in machine learning industry as well as in literature. So our research question, like what is the perception and current treatment of non-functional requirements in machine learning among practitioners? So we divided our research questions in 8 sub questions, and here I'll not present all. I'll present few. So first one is, which machine learning related non-functional requirements are more or less important in industry? Or what aspects of the system, which is machine learning enabled system, are non-functional requirements defined? What non-functional requirement and machine learning related challenges are perceived? Over what aspects of the system are non-functional requirements measured? Then what measurement related challenges for non-functional requirements is in and machine learning context exist? And the last one is there a difference of perspective for practitioners working in different contexts regarding non-functional requirements in machine learning enabled systems? This context are from industry people, academic people, or blended context. So our research methodology, we choose interview as a method to collect in-depth information through open-ended questions. And then we performed a wider survey to validate these interview results and extend the results. Then we selected practitioners who are working in machine learning and non-functional requirements in the industry for our interview study. And we interviewed 10 participants from different industry who are working with machine learning and requirements engineering. And then we, in survey, we allowed both industry people as well as people from academia for data collection, and we received 30 participants results. Then at first, to refine the collected data, we collected demographic data, and according to participants' demographic data, we refined the results, and we collected non-functional requirements related data and non-functional requirements measurement related data from the participants. And for qualitative data analysis, we performed thematic analysis from the interview, and we performed statistical analysis for analyzing the survey data. So results. So these results is from interviewed. The interview was the data collected from interviews were mostly qualitative, and we divided this qualitative data mostly in 5 measures themes, which are defined over measurement over challenges, importance, and captured, and which were divided into different smaller sub themes. Then answer to the research question 1, which machine learning related non-functional requirements are more or less important in industry? So we found the most non-functional requirements which are relevant for traditional softwares, those are also important for machine learning enabled systems. For example, accuracy, reliability, usability, these non-functional requirements got more attention from the interviewees. And the C is the number of participants answered that accuracy is important for machine learning enabled systems, and F is the frequency, that means how many times they said it is important in machine learning enabled systems. And a very few non-functional requirements which are mentioned are less important in machine learning enabled systems. For example, usability, flexibility, efficiency, testability, product revision, portability, reusability, and product transition. And the yellow background, like there is disagreement among the participants about the less important, the yellow background, which are considered as less important by some participants, as well as more important by some participants. So usability, that is considered important by some participants, as well as less important by some participants.
Who was the audience here? What background did the people have that you interviewed?
They are working with machine learning as well as requirements engineering.
Okay, so mostly engineers.
Yeah, they're mostly engineers. Interviews were solely in the industry. There was no academic people as participants. But survey, we allowed industry people as well as academic people to respond.
And what level of seniority did they have?
According to the demographic data, all of my, if I make an average, they have more than 10 years of experience. But for the interviewees, but for survey, they have less experience.
Could you just, how do I read this graph? Is the top row, is that most important? Or
yes, top rows are most important. Like here you see 8 for accuracy, 8 participants out of 10,
okay,
they said it is important. Reliability, 5 participants said it is important. They said 9 times this is important in different time. As well as like here usability, the top rows are they said frequently. Then regarding this, we asked the similar question in the survey for important or less important, identifying important or less important non-functional requirements. And for starting, we asked if non-functional requirements play important role in ensuring the quality of machine learning enabled systems or not. And we found that all the participants said that non-functional requirements are very important for ensuring quality of machine learning enabled systems. And we asked if there is difference on how non-functional requirements are defined and measured between traditional systems and machine learning enabled systems. And we found that 23 participants out of 30 said that, yes, there is difference. And 2 participants say that disagreed that there is no difference of defining and measuring non-functional requirements for machine learning enabled systems. Then this is the and the non-functional requirements which are important for machine learning systems we identified in interview study, and we put all those non-functional requirements in survey. in a scale of 5 to 0, if they strongly agree or how much importance they put on each non-functional requirements. And we found that overall results here, like accuracy, integrity, reliability, security, they got most importance. Like here for accuracy, 27 participants out of 30 said accuracy is important. Very important, and no participant said, sorry, all the 30 participants said that accuracy is important, and the blue one is like 17 participants said that this accuracy is very important. The same as integrity, reliability, and very maintainability, portability, simplicity, and interoperability. These non-functional requirements got less importance among the participants. And there are some other non-functional requirements which where I didn't know. Participants said that these are not important for machine learning enabled systems. For example, accuracy, then reliability, then maintainability. No participants say that these are not important for machine learning enabled systems. Then,
can I ask another question?
Yes, sure.
Are these explicit or implicit non-functional requirements, in the sense that have these participants experienced that some stakeholder has explicitly put these requirements on them, or are they requirements they have experienced that are sort of implicit in what they need to perform to?
Yeah, most of them are working with real machine learning enabled systems, and they ensures this kind of qualities for their systems.
Okay, so they put these requirements by themselves?
Yes.
Okay.
For enabling the quality of their systems. Then we divided we filtered these responses according to their backgrounds. So these are the responses, especially from industry participants. So industry participants most highly value reliability, accuracy, integrity are the most important. They placed higher importance on justifiability, interoperability, interpretability than academics actually. If I compare responses from industry people as with academics, so they put high importance on justifiability, interoperability, and interpretability. Then these results are from academic participants. They put more importance on accuracy, completeness, integrity, and reliability, and less importance on justifiability, usability, transparency, and explainability. However, participants from academia offered more consistent ratings of the importance of non-functional requirements, but they also, on average, they also put lower ratings. For example, the industry people, if I consider industry people, they put over on average 4 for the importance of non-functional requirements. Like the scale was 0 to 5, and the industry people put on average 3 for the importance of non-functional requirements. And the academic people put higher importance on fairness, maintainability, and transparency than industry participants. And these results are from blended context, who has both academic and industry positions. So participants from blended context placed higher importance on fairness, transparency, explainability, justifiability, and privacy than other groups. And they also placed highest average importance on non-functional requirements, but they had higher variance on their responses. So some of them put less importance on many non-functional requirements, and some of them put very high importance on these non-functional requirements. And they placed lower emphasis on fault tolerance, portability, and simplicity. Then we know that machine learning is very small part of a larger system, and we can define these quality requirements on data, then machine learning model results, or overall the whole systems. So by considering this, we asked people or participants over what aspects of the system non-functional requirements are defined as well as you measure. Then we found that the industry people normally measure non-functional requirements over the whole system, but academic people, they say that these non-functional requirements can be measured. And academic people say that non-functional requirements can be measured over the machine learning model. So non-functional requirements definition is scope. So academic people say that non-functional requirements can be measured over the whole systems. Most of them said most of the industry people said the whole system, and the blended context, they also say that most of them said that non-functional requirements can be measured over the whole system. So normally, then we can decide that we need to measure and define these non-functional requirements over the whole system. Then we also asked, non-functional requirements measurements for machine learning enabled system can be dependent on other non-functional requirements defined for the other parts of the system, the whole system, the machine learning model, or the data. And most of the participants agreed on this statement. And we also asked that non-functional requirements measurement can be dependent on the context. And most of the participants also agreed with this statement.
So some are missing. If it started out with 30 answers, why is
these questions were answered by 28. Like, not all the participants answered all the questions. Okay. That's why we have less for some. Then we asked participants what non-functional requirements and non-machine learning related challenges are perceived. And from interview, we found that there are many challenging non-functional requirements and challenges regarding uncertainty, domain dependence, awareness among participants as well as engineers. There are regulations as well as dependency among requirements, which are the challenges on defining or non-functional requirements or non-functional requirements related. And we again asked what measurement related challenges for non-functional requirements in and machine learning context exist. And we found measurement baseline, complex ecosystem, lack precise practices, lack of knowledge, data quality testing, problematic requirements, and domain dependence are challenges for measuring non-functional requirements. Then in survey, we asked the similar type of questions, which percentage of time you experience challenges by defining and measuring non-functional requirements. And these specific challenges are not emerged in all projects, but however, 76% of survey responded that they encountered at least one of these challenges in their machine learning enabled systems or projects. Then we specifically asked the identified challenges to the survey participants, like lack of awareness among engineers about non-functional requirements for machine learning enabled systems is a challenge. Uncertainty is a challenge or not. Lack of awareness is a challenge or not. Rigorous testing is a challenge or not. And from the results, we see that most of the survey participants says that these mentioned non-functional requirements, mentioned challenges, they experience in their projects. Then we compared responses with industry people, with academic participants, as well as with blended context. So here, domain dependency and lack of awareness, we see that academic participants are mostly strongly or agreed that lack of awareness and domain dependency are challenges for their projects. And here, lack of awareness among customers. One industry participant said that it's not a challenge. And in regards to implementing rigorous testing and lack of awareness among engineers about non-functional requirements for machine learning-enabled systems is challenge. Here, normally industry people say that these are the challenges. So no one from industry disagreed on those statements. Then we also asked uncertainty is a challenge or not, and missing measurement baseline is challenge or not. So those from all three contexts largely agreed that missing baseline and uncertainty is a challenge. However, those from blended group show weaker levels of agreement on these two statements. So this is all from me. So if you have any questions.